Hello everyone, today we're going to talk about relative minimum and maximum, or relative minima and maxima. And we're going to use the information in order to sketch graphs. A point x1 and f of x1 is a relative maximum point of the function f if there is an interval around x1 on which f of x1 is greater than or equal to f of x for all x in the interval. In this case, we say that the relative maximum occurs at x is equal to x1, and the relative maximum is f of x1. In other words, we say that a point is a relative maximum point if in a specific interval, that point is the highest point on the graph. The point x2 and f of x2 is a relative minimum point of the function f if there is an interval around x2 on which f of x2 is less than or equal to f of x for all x in the interval. In this case, we say that the relative minimum occurs at x is equal to x2 and the relative minimum is f of x2. In other words, we say a point is a relative minimum if there is an interval that contains that point and every other point on the graph is higher than that, or it is the lowest point on that interval. To illustrate that, we're going to look at the following graph. So we say a point is a relative maximum. I see here that I do have a relative maximum at this point. Let's say it is at x1 and the relative maximum is f of x1. If you look at this interval from a to b, you will notice that on this interval, f of x1 is the highest point, so it is a relative maximum point. Similarly, I see here that I have a relative minimum. If you look at a specific interval, let's say this interval from a to b, you will notice that f of x2 is the lowest point on that interval, on that specific interval, and that makes it a relative minimum. To determine whether a turning point of a function is a maximum point or a minimum point, it is frequently helpful to know what the graph of the function does in intervals either side of the turning point, meaning we want to see the behavior of the function around that point, on either side of that point. We say that a function is increasing on an interval if the values of the function increase as x values increase. Meaning if you scan it from left to right, it's going upwards. We say that a function is decreasing on an interval if the values of the function decrease as x values increase. Meaning if you scan it from left to right, it's going to go downwards. If the function f of x is differentiable over an interval, and if each tangent line on the curve over the interval has a positive slope, then the curve is rising over the interval and the function is increasing. Because the derivative of the function gives the slope of the tangent to the curve, we say that if the derivative of the function f prime of x is greater than 0 on an interval, then the function is increasing on that interval. A similar conclusion can be reached when the derivative is negative on the interval, meaning if we have f prime of x is less than 0, we can say that the function is decreasing on that interval. That will lead us to the following conclusion. Let f be a function that is differentiable on an open interval, ab. If f prime of x is greater than 0 for all x in that interval ab, then f is increasing on the interval ab. If f prime of x is less than 0 for all x in the interval ab, then f is decreasing on the interval ab. To visualize that, let's look at the next slide. Here is a graph of a function. Look at the tangent line at that point. The tangent line seems to be going upwards. That means it's positive. We can infer that f prime of x is positive as well at that point. So we can say f prime of x is positive at that point, specific point. So in this case, f prime of x is greater than 0. In this case, we notice that the slope of the tangent line is equal to 0 because it's horizontal. So we can say that the slope of the tangent line, which is f prime of x, is basically equal to 0. If we look at the next tangent line, you will notice that this tangent line is going downwards. If you scan it from left to right, it's basically going downwards. That means that the slope is negative, and in other words, we can say f prime of x is less than 0. If we keep doing that, we will notice that we have another tangent line at this point. And as you notice, the tangent line is horizontal. That means the slope of that tangent line is equal to 0. In other words, we can say f prime of x is equal to 0. And if we keep going, this is another tangent line and it's going upwards. That means it's positive. That means f prime of x is basically greater than 0 because the slope of this tangent line is positive. Notice from the previous graph that we have horizontal tangent lines at certain points where the graph of the function changes from increasing to decreasing and from decreasing to increasing. As you'll notice here, we have f prime of x is equal to 0 when it's going from increasing to decreasing. And we have another f prime of x is equal to 0 when it is coming from decreasing to increasing. The point at which the graph of the function changes behavior is called a critical point, and the value of x where the graph of the function changes behavior is called the critical value. A curve changes from increasing to decreasing at a relative maximum, as we noticed from the previous graph, and from decreasing to increasing at a relative minimum. Notice here how we have a relative maximum that is called a critical point, and that critical point happens at a critical value. So this value of x is basically the critical value, and then it's going to give us the critical point, which is in this case a relative maximum. Notice how the relative maximum is happening, where if I take the tangent line here, the slope of that tangent line is going to be 0, meaning the tangent line is going to be horizontal. Again, we have another relative minimum point, which is a critical point at a critical value of x. So at this x, when we have a critical value right here, we're going to get a critical point or relative minimum because the behavior of the function is changing from decreasing to increasing at that point. Notice again, if we take a tangent line at this point, the tangent line is going to be horizontal. That means the slope of the line is going to be 0, or f prime of x is equal to 0. That will lead us to the following theorem. So if we have f that has a relative maximum or a relative minimum at x is equal to x naught, then f prime of x naught is equal to 0, or f prime of x naught is undefined. So if we want to find the relative minimum or maximum, we have to find the derivative of the function, make that derivative is equal to 0, and then determine every point that makes the derivative is equal to 0 or it makes the derivative undefined. Here is a graph, and we have relative maximum and relative minimum points in this case. The first point happens at x1, and this is basically a relative maximum. You notice that a relative maximum happens when f prime of x is equal to 0, or the slope of the tangent line is equal to 0. This is what it means. Another point happens when x is equal to x2, and we have a relative minimum. Again, that relative minimum happens when the slope of the tangent line is equal to 0. In the third case, it happens when x is equal to x3, and if you notice here, if you sketch a tangent line to the graph, it's going to be vertical line. That means the slope of the tangent line is going to be undefined. Basically, if you have a sharp point like this one here on the graph, you know that the derivative at that point is undefined. So that is another relative maximum, and it happens when the slope of the tangent line is undefined, because if you draw that tangent line, you're going to get a vertical line, and the slope of a vertical line is undefined. The process to find the relative maxima and minima of a function, we first have to find the derivative of the function. Next, we set the derivative equal to 0 and solve for the values of x that satisfy f prime of x is equal to 0. Those are called critical values. Also, values that make f prime of x undefined, those are called critical values. So we need to find all of the values that make f prime of x equal to 0 or undefined. The third point, or the third step, is to substitute the critical value into the original function to find the critical point. The next step is to evaluate f prime of x at a value of x to the left and 1 to the right of each critical point to develop a sign diagram. We're going to create some intervals and test those intervals, whether the function is increasing on those intervals or decreasing on those intervals based on the sign of f prime of x. The last point is to use the information and the sign diagram in order to select points and sketch the graph eventually. So let's look at some examples. The first example, we want to find relative maxima and minima of the function f of x is equal to 1x minus x squared minus 3x plus 2, and then sketch the graph. So the first step in order to find the maximum and minimum point, or maxima and minima points, is to find the derivative of the function f of x, or the first derivative of the function f of x. So to find the derivative, we're going to say f prime of x is equal to x squared minus 2x minus 3. Please make sure that this is correct by differentiating the original function. So that work is up to you to do. We're going to differentiate this function in order to find f prime of x. The next step, we're going to find all of the critical values. The critical values are basically all of the values that make f prime of x is equal to 0 or make it undefined. Since I don't have any values here that make f prime of x undefined, the next step will be to find all of the values that make f prime of x is equal to 0. So I'm going to set x squared minus 2x minus 3 equal to 0, which is f prime of x is equal to 0. And then I'm going to solve for x. This is a quadratic equation. We're going to factor that quadratic equation and then solve for x. So I'll factor it to x minus 3, x plus 1 is equal to 0. If I put each factor is equal to 0, I can solve for x easily. So I will have x is equal to 3 and x is equal to negative 1. So I have two critical values in this case. And again, a reminder, there are no values that make f prime of x undefined since I don't have any denominators. I don't have any radicals. So I don't have to worry about this function being undefined at any point. So the only critical values that we have are x is equal to 3 and x is equal to negative 1. Now let's create some intervals. So on the number line, if we have an open number line like so, we have the point negative 1 here because it's a smaller one, and the number 3 here. So if that happens, you'll notice that that number line is cut into 3 portions. The first portion, or the first interval, is from negative infinity to negative 1, and we're talking about open intervals in this case. The second interval is from x is equal to negative 1 to x is equal to 3, so that is the second interval. The third interval is from x is equal to 3 to x is equal to positive infinity, so from 3 this value to positive infinity continues. We want to see what is exactly the behavior of the function so we can determine whether this point right here, which is we're going to find eventually, is it a minimum point or a maximum point. So let's do that in the next slide. Here I am going to build a sign diagram. This is a table basically containing the intervals that I want to test. I want to test the behavior of the function on those intervals. So I will choose some test values. Test values are values that belong to that interval. I want to find a number that is between negative infinity and negative 1. The easiest number is negative 2, so I chose that number. And then I want to find a number that is between negative 1 and 3, so I chose 0 because it's an easy number to work with. And again, I want to choose a number that is between 3 and positive infinity, and that number is 4. Then to find the behavior of the function on that interval, I'm going to test the sign of the derivative of the function. Because if the derivative is positive, that means the slope of the tangent line is positive. And if it's positive, that means the function itself is increasing on that interval. Now I'm going to plug -2 into f prime of x. So if you plug it, you will get number 5. I don't care about the number itself as much as I care about the sign, and the sign is going to be a positive sign in this case. So a positive sign in this case. Again, I'm going to plug 0 into f prime of x. You will get -3 as a result. I care about the sign only. If you plug 4 into f prime of x, you're going to get 5, which is a positive sign. Now the conclusion. I would conclude since this is positive, then the function is increasing on the interval from -infinity to -1. And since this answer is negative, the function is decreasing on this interval from -1 to 3, and it is increasing from 3 to positive infinity. So here is my number line again. I have at -1, I have at 3. So if you compute the critical point, in this case, to find the critical point, you plug -1 into the function, the original function. If you do that, you're going to get 11/3, so we will get the first critical point. And then the second critical point, you plug 3 into the original function, you will get 3 and -7. Here I made illustration, so I know that on the interval from -infinity to -1, the function is increasing, so I drew a tangent line that is going upwards with a positive slope. And then on the interval from -1 to 3, the function is decreasing, so I drew a line that is decreasing going down. And then on the interval 3 to positive infinity, I drew another line that goes upwards because the function is increasing on that interval. So that will give me an idea of which critical point is actually a relative maximum and which critical point is a relative minimum. In this case, I noticed that -1 and 11/3 is a relative maximum, and 3 and -7 is a relative minimum. Now let's use the previous information in order to sketch the graph of the function. What do we know about that function? We know the following. We know that -1 and 11/3 is a relative maximum, and we know that 3 and -7 is a relative minimum. We know that the graph increases before -1 and 11/3 and decreases between -1 and 11/3 and 3 and -7, and increasing after 3 and -7. In other words, it is increasing on the first interval from -infinity to -1. It is decreasing from -1 to 3. It is increasing from 3 to positive infinity. Now let's sketch the graph. I sketched the relative maximum and the relative minimum point. Now I'm going to sketch the graph. I know it has a relative maximum here, and then I know this is a relative minimum, so I'm going to sketch those points. You will notice that the graph before -1 on the interval from -infinity to -1 is increasing. The graph between -1 and 3 is decreasing on that interval, and then it is increasing from 3 to positive infinity. So if I connect those dots and try to sketch that graph, the graph might look something like that. And that is the final sketch of the graph. I hope this was helpful, and I will see you in a different video.